Hello and welcome to this repair tutorial, and today we're going to look at a NAD and the model number is 314. In terms of general specifications, continuous average power output is 2 times 35 watts into 8 ohm speakers. A nice feature is that you can also connect dual sets of speakers, and via the front panel you can select a secondary set. In terms of frequency response, it's 20 Hz to 20 kHz. Total harmonic distortion comes in at 0.03%. And then for input sensitivity, you can connect directly a turntable with a moving magnet type cartridge, and that's 2.5 millivolts at 47 kiloohms. And then for all of your other inputs, which we refer to as your line inputs, it's 170 millivolts. Input impedance here is 20 kiloohms. You can also connect headphones for private listening via the 6.5mm jack socket on the front. And a nice feature with this amplifier is on the back you have links, which is very common with NAD amplifiers. And if you wish, you can decouple the preamplifier and the power amplifier, meaning that you could connect additional preamplifiers and drive the output stage of the amplifier independently. Or alternatively, you may feed the preamplifier output into other power amplifiers. The amplifier also has individual bass, treble and balance controls. You can bypass the tone control circuits via the tone defeat switch on the front. And then in terms of dimensions, 435 width, height 110, 310 millimeters deep, with an overall weight of 8 kilograms. Now this amplifier is manual operation, meaning that it does not have a remote control to put the amplifier into standby mode or select any inputs or operate the volume control. And then here, if we take an aerial shot, you can see this is quite a busy picture. You can see here you have these long plastic actuators which connect to a bank of rear selection switches which are near to the input RCA sockets. On the right hand side, and we'll look in a moment at another photograph with a little bit more detail, you have the final input stage. Then you have the regulated power supplies with fuses, relevant rectification, regulation and smoothing. And then on the left hand side you can see the larger electrolytic capacitors, and then just out of view you have the speaker protection relay. And then you can see the bank of driver and output devices all bolted to the heatsink. Now, what was the issue with this amplifier when it came into the workshop? Well, it was the most common issue that you find with many amplifiers, and that is intermittent loss of sound. And it can either be on the left channel or on the right channel. Sometimes the owner can describe is if they increase the volume, then sometimes that distortion can go away, or all of a sudden the audio then can be heard or it bleeds through. What I'm pointing to is the speaker protection relay, and this is a 24 volt double pole, and it's a changeover relay, so you have independent contacts, one for left and one for right. Now you could attempt to remove the top cover off this relay and maybe clean the contacts, but as always with the repairs that come into the workshop, I just replace the relay. It just provides that nice longevity, and also the relays that are fitted are of a higher quality than this unit, and then also as well it's a sealed unit, so you're going to get less oxidization because it's not open to the atmosphere. You can also see with this amplifier it's very dusty, and part of the repair procedure of course is to clean out all of that dust. And then here what you can see is the EI power transformer, and not substantial, this isn't a hugely powerful amplifier. And then here what I've done is I've just took off the bottom service plate, and the reason why I'm showing you this is of course we need to desolder the speaker protection relay, but also as well there are certain areas on the circuit board which have stress points, common with all amplifiers, so you need to be scanning this circuit board just to look out for any cracks that you may be seeing around some of the solder joints, and also pay particular attention to where you have power components. The board heats up and you'll see discoloration of the solder joints and ultimately dry solder connections. So just take your time, scan each one, resolder as needed to, but always be very, very careful not to have any solder bridges, so always check your work before you power up the amplifier back on. And then here is just the zoomed in view, and you can already see that the circuit board is being cleaned up, normally done with a compressed air line and then also a stiff brush. And to the rear, you'll see in a moment is the phono stage, but it just zooms in just on the low voltage power supplies. And what you find with these amplifiers is there are high quality components fitted throughout, and I wouldn't say that the amplifier is bad in terms of design. You don't tend to get issues like on some of the other C series of amplifiers which use these JH capacitors. And this is a close-up view now of the moving magnet type cartridge input. So you can see that there is no integrated circuit that is being used for the equalization and preamplification. All of this is done via discrete components, so resistors, capacitors, and semiconductor devices, i.e. transistors, and also diodes. Now, once the speaker protection relay was replaced, of course, you have to carry out some other remedial work as well. So as always, you need to use a high quality switch cleaner like De-Oxit D5 and spray into all of the different switches and also into the user control. So that is the volume control potentiometer, the balance, bass and treble. And you need to operate these multiple times just to ensure that you have reliable, repeatable and noise-free operation. The good thing for this amplifier was never been stored in a damp, humid environment or even a smoky environment, which meant that to clean up all of the switches was relatively straightforward. Also as well, don't forget to spray some switch cleaner directly into the headphone socket and just connect the jack plug multiple times and then just rotate it just to clear off any oxidization which may have accumulated over time. And then here what we see is an extract from the service manual, and what you can see here is the left channel as it says. And what we're looking to do is to make two sets of adjustments. With this amplifier you have the ability to actually adjust the DC offset, which is measured across the rear speaker terminals. So again, the amplifier will be turned on normally for about 20 minutes, and then you will then connect your multimeter, and what you're looking to do here is to adjust the preset. So here it's RV301 until you have a reading as close to 0 millivolts as you can. The tolerance here is plus or minus 10 millivolts, so as long as it's within that range, then that is fine. That would be as per the factory adjustment. And then the other thing that you have to do is you have to adjust the bias for the output channels, and here you can see that the range is 5.7 to 6.4 millivolts. Now what's interesting is that you just have pegs which lift up from the board, and they're referred to as the test points. So for the left channel it's test point 301 and test point 304. And then if you're going to be doing the right channel, then it'll be 302 and 303. Again, if you're making these measurements, if for whatever reason maybe they seem a little bit coarse, just turn off the amplifier, spray the presets then with high quality switch cleaner, just rotate them backwards and forwards, move them roughly to the original position, and then you should be able to power back up and align it very cleanly. And then here what I'm showing you is just a series of photographs just confirming the operation of what we've done here. So this one here is a DC offset on one of the channels, and you can see that it's very, very low at 0.46 millivolts. And then here, the other channel is 0.67 millivolts. And then when we look at the bias adjustment, you can see here that we've adjusted the channel now to 6.01 millivolts, and you can just about make out the hook clips as they connect to the vertical test pins. And then on the other channel, just underneath at 5.65, but what I will always do is just to leave the amplifier running and then just to make final adjustments. And then here, if we take an aerial view, you can see now that the amplifier really has been fully serviced. So all dry joints have been reflowed, all switches and user controls have been cleaned. We've also verified the ASR of the capacitors as well, none of them required to be changed. And then we've also replaced the speaker protection relay. And then here, if we take a zoom in view, you can see that this is the original relay. So as I said, it's 24 volt DC coil. Contact switching is rated at 5 amps, and you have a common and then normally open contact, which will close when the relay operates. And then once all that has been done, the only final part really is to clean the amplifier and then to put it onto test. So this amplifier ran for nearly 4 hours, and again faultless in operation, just making sure that both output channels in terms of a test 1 kHz sine wave applied is equal, no distortion, and then also as well to switch between each of the different inputs just to make sure that you've got consistency and there's no issue with noise or maybe static. So that sort of brings us to the end of this repair tutorial. So again, if you require any help, assistance or support, by all means email audioamplifierservicing@aol.com and I'll be more than happy to come back to you and provide the support. So until the next time, I wish you all the very best. Cheers and bye-bye.